This video focuses on Java exceptions. So far with the code and the labs we've written, we're focusing on functionality, how to get something done. We're not focusing so much on what happens when the unexpected happens, when an error occurs. There's many ways to deal with errors. You could just return some sort of error code from your methods. You can print out warnings. But Java has a built-in construct just for dealing with what happens to code when the unexpected happens. And these are called exceptions. Something exceptional happens in your code, you can use an exception to handle it. So let's look at what this is in code. Now I have an example of a file translator, and if we look at our main is actually going to use command line arguments, and these come in through our string array args in our main. This is an array of strings, and if you put on the command line, if you have arguments, that means space separated values after your run, then they come in this args array, and you can just index them like you would any other array. So we get our command line arguments, and in this case, the first one's going to be the input file name that we're going to translate, and the output file name, the name of the file we're translating to. So one is going to be a file that we need to open as a read file, and the other one's going to be the name of a file we need to open as a write file. So we go ahead and create our file translator object, passing in our strings for our file names, and then we're going to call translate. Now you notice this new keyword, couple keywords here, try and catch. This is called a try catch block, and try means you're going to see if any of this code is going to throw an exception, or if it's going to have any of these errors or exceptional situations happening that we may need to handle that case. And some examples of exceptional cases are if we have a reference which is null and we're trying to use it somehow. If we try to divide by zero is not a mathematically defined operation, so how do we handle that? Those are a couple examples. We can have an array go out of bounds if we try to index into an array where like say there's 10 elements in an array and we try to access the 11th, we'll get an out of bound arrays exception. And you've probably seen some of these as you've been working with your earlier labs. But those are just a few. We are going to be looking at the legal argument exception and our IO exception in this example. We're dealing with IO exceptions because we're dealing with files. Files are considered input and output. And we're going to actually have to try to open our files and read and write to them. And anytime that happens, errors can occur. An incorrect file name could be specified and that file doesn't really exist on the disk, so there's no way to open it. That would be an IO exception. If you come to the end of a file and you're still trying to read data, that would be considered also an IO exception. So that's something we actually have to catch. If we don't, we'll get an error because this is what is called a checked exception. And then we're also handling an illegal argument exception, and that's because in our example here, we're expecting text files to go in and text files to go out. So we're going to say if our file does not end with a txt extension, the input or the output, that we've just received an illegal argument and we can't handle that. So we're going to throw an exception and then it's going to be caught and dealt with here. So let us go look at our file translator class. So I've imported a file reader, file writer, my IO exception, and my illegal argument exception. And exceptions are all derived from a base class, just a plain exception. And if you wanted to just handle every exception, let's go back down to our main. Instead of catching these explicitly, you could say catch exception E, and you would capture every exception that is known to Java. Why would you not want to do that? Well, it can be expensive, and also you don't get any of the specific functionality or specific messages or something that you might get with the exception. In this case, we're really not using that. We're just using a generic get message method, but there could be something specific that you would want to get out of the exception object. Okay, so I declare my file reader and my file writer, and I declare file translator, taking in my two strings, throws IO exception. So this is another new keyword. The throws IO exception is telling the user who might be using the file translator that this method will throw this exception somewhere in the method body, and it does not catch it. It needs to be catched outside of the method, which is exactly what we do if we go back down and look at our main again. We are trying to see if that exception happens, and we're going to catch it. We're going to catch the IO exception here. If we don't do this, we actually get a compiler error. Okay, so within our file translator, we're going to look at our strings that are coming in and make sure that they end in the .txt, because we're going to assume that if they're not ending in .txt, then they're not a text file. And if they're not a text file, then they are an argument we can't accept. And we're going to go ahead and throw an illegal argument exception. Again, a new keyword, throw, not to be confused with the throws. And then we go ahead and pass in a message telling exactly why it's considered an illegal argument. So once we've checked that, we're going to go ahead and try to open our files with file reader and file writer. Now, these two constructors both can throw IO exception. So we do another try catch block, and we try to catch our IO exception. And then there's this other clause as part of the statement. We have our try catch and finally. And the finally is something unique for the exceptions, because what can happen a lot of times is you'll have something happen in a try block or a catch block. You'll have an exception thrown in your try, and it'll go to your catch, and your catch will deal with the exception, and then it exits. It's going to exit after you get into your catch block. It's going to exit your function. Well, what happens if one of these files actually opened correctly and one of them did not? One of them throws an exception. We're going to catch the exception here, print out, and return immediately, which ends up giving us a open file handler that should really be closed because it's not going to be used. So you end up having resources that haven't been cleaned up. So this finally block is added, and finally will run no matter what happens in your try catch block. If the catch gets executed, it will still run. If the catch does not get executed, finally will still run. So what we do in this example is finally is going to make sure if either of our files actually did open, and if they did open, they would not be null. It will go ahead and close the files for us. And now here we're getting into multiple levels of exceptions because since close is an IO method that will throw an IO exception, again, we have to catch the exception. And in this case, we just take it and throw it again and give it to some higher method higher up in the call stack to deal with. And I do the exact same thing for the output file. All right. So kind of to recap again, we go ahead in our main and put a try-catch block around our creation of the file translator because we know it's going to throw two exceptions, or could throw two exceptions, an illegal argument exception and an IO exception. Now you don't see the throws statement including the illegal argument exception. And that's because the illegal argument exception is considered an unchecked exception and does not have to be handled. Where the IO exception is something that is considered a checked exception and so must be handled. So I'll go ahead and compile. And then, since this program takes command line arguments, we're going to run this on the Dr. Java Interactions console. So I'm going to type Java and then file translator. And then I'm going to specify two files. I'm going to say in is the name of one and out is the name of another. And what do you think will happen when I run this? We get the printout. Argument usage, input and output files must be text files. So what happened here? So we got our arguments coming in. We passed them into our file translator. It checked the files that the file names actually end with .txt, and they don't. So it goes ahead and throws the new illegal argument exception. It's not caught in the constructor, so it will fall back to our main. In the main, it does get caught. In the main, we're going to print out argument usage saying like, you need to use the argument differently. And then we use the message that we passed in during the constructor throwing of the exception. And so that's how we get argument usage, input and output files must be text files. Let's try running again. This time, let's fix our argument error and do in.txt and out.txt. Now in.txt and out.txt don't exist on my file system, so what do you think will happen this time? Now we get provided file arguments failed to open. In.txt, no such file or directory. And this comes from now trying to open the files. Once we get past this throwing of the illegal argument, we want to do is open up the files. Now opening up the files could cause an IO exception. So we catch that right below, and we're going to print out provided file arguments failed to open, and then get the message that comes from the IO exception itself, which tells us which file it had a problem opening. Now neither one exists, but we get the exception because the exception is going to be first thrown by this call to file reader. The file writer one doesn't get a chance to even run because we exit the call stack with the exception from our file reader. So I'm going to post this code so you can take a look at it and have a good time with the lab. We're going to be throwing our own illegal argument exception and catching it within the game.